decide if the given function is continuous or not. If it is not, then state the reason it is discontinuous or it's not continuous. So we have y is equal to the greatest integer function. It's a function that gives the largest integer, which is less than or equal to x. So let's start by drawing a picture. So we have our coordinate plane here. And it looks something like this. And we could plot a point down here. There's the open circle and closed circle here. So here's what our greatest integer function looks like. Let's go through all the criteria to see whether or not this is a continuous function. Does f of a exist for all a values in our function? Well, we can see both to the left and to the right, for every a value, there is a function value. And there is no repetition. Here at positive 1, we have an open circle at 1, 0, but we have a closed circle at 1, 1. So there is no overlap at all within the function. And f of a does exist for all a values in the function. Therefore, B is not the correct answer to this question. Does the limit of f of x as x approaches a exist for all a values in this function? Well, it actually does not. At all of the endpoints of our greatest integer function, we can see that as x approaches 1 from the left, we're at 0, and as x approaches 1 from the right, we're at 1. So we can see that the limit of f of x as x approaches a does not exist for all a values in the function. At every single integer value, that's where the discontinuity occurs. So the answer to this question is C. The next answer doesn't really need to be examined, because if the function fails, like if the limit of f of x as x approaches a does not exist, then you can't really make it equivalent to f of a to do this other test. So that's why the answer here is C.